So today I'm going to teach you how to name compounds with polyatomic ions. So one thing to note here is that polyatomic ions, I have a chart here, they will be negative. So they're going to want to pair with metals, which will be positive. So if we go back here, we notice all of these first starting parts are metals because the polyatomic ions at the end will be negative and want to pair with those positive, or will become positive metals. So if we look at this, the first part of the formula is the regular, and it's hard to see, but there's K2C or SO3. First part is just the metal, and the second part is the polyatomic ion. So we name the metal just as you see at on the periodic table. So if you look at the periodic table, you will find that K is potassium. Now for the SO3, we have to base it on the parent polyatomic ion. And what that means is basically there's a polyatomic ion that will have several other polyatomic ions basically the same except differing in the amount of O's, so oxygens. So there's a naming scheme of the polyatomic ions that differs with the amount of oxygens. So if we have the parent ion, polyatomic ion, then it will end in 8. If we add an oxygen, it will start with per and end with 8. If we remove an oxygen, it will end in 8. If we remove 2 oxygens, it will start with hypo and end in 8. So a way to remember this is it goes from the most oxygens to the least. And the first 2 end in 8, the last 2 end in 8, and the first one has a beginning and the last one has a beginning. So that'll help you remember that. So we have to find out what the parent polyatomic ion of SO3 is. So if we look at our little chart here, we have to look for SO3, or SO, because the O can differ if that's not the parent polyatomic ion. So we look for SO. We see there's 2 SOs here. We have to look for the one that ends in 8. So that is sulfate. So here we see that sulfate has O4. Well, we have 1 less O. So remember, when you subtract an O, it changes to ite. So we will have sulfite. And I will put that in blue. There we go. Next, we have Mg, and then CH3CO2, and then all of that is times 2. So not the Mg, but the CH3CO2. Since it's in brackets, it's times by 2. Which won't affect anything here, but just to note. So Mg, if you look on the periodic table, is magnesium. We'll write magnesium, and we won't write that in blue, because then you'll think that has to do with the sulfite. And then we have to look for this parent polyatomic ion. So we'll look at our chart, and we don't see it exactly like CH3CO2 too. We won't see that. We won't even see this 2 because that's just multiplying. That doesn't have anything to do with like the basic polyatomic ion. It just means in this formula they combine in a ratio of 1 magnesium to 2 of these, which is acetate. Now we look at our table, we see C2H3O2, and that looks a little bit different than CH3CO2, but it's the same thing because here we have C2. Well, we do have 2 C's here. It's just they're separated. And the rest are the same, H3 and O2, and as we see, H3 and O2. So, we look, and acetate is the polyatomic ion, and it has the same number of oxygens as the one we have here. So we just name it exactly like it's named there. So, acetate. Magnesium acetate. Perfect. So now we have LiClO4. So we know the first part is just going to be lithium. If we look at our periodic table, we can see that. And then we have ClO4. So we want to find out what the parent polyatomic ion of that is. So we look for Cl. There's a bunch of Cl's. There's one up at the top of the second table and 2 in the middle of the first. So we see here that the one that ends in 8, chlorate, is ClO3. Well, we have ClO4. So what do we do when we add an oxygen? Well, we start with her, then we put the middle of the name, so chlor, and then add 8 at the end, so lithium perchlorate. And that is all there is to that. See you next time.